Okay, so today we're going to cover segment addition, segment bisectors, and then midpoint of segment. So let's start off at the top with the segment addition postulate. So it says here that the definition is that given 2 points A and C, a third point B lies on the same segment AC if and only if AB plus BC equals AC. So let's talk about what that means. So if I have this line segment AC, so I have my line segment AC, and it says that a third point B lies on this segment. So we can put that B point anywhere. So let's place it right there. So then here it tells us that if we do AB plus BC, so that's the smaller part of the line segment here, and we add this bigger part of the line segment, it gives us the whole thing, which makes sense, but just in case you're still kind of struggling with that concept, if this side from A to B was 2, and from B to C was, let's say, 8, then we would add 2 plus 8 to get the length of the full segment, which would be 10. And so that's all this says right here, just says it in segments. All right, so let's look at an example. So right here, this first example says that if C is between D and E, so C is going to be the point that's in between D and E, so let's draw that out. There's D and E, and C is between it somewhere. We'll say there. All right, then it gives us that DC is equal to 1/2 4x plus 6. So that is this section here, 1/2 4x plus 6. And sometimes labeling these things just helps so you can see it visually. All right, so then the next segment it gives us is CE. So CE is 3x plus 1. I'm going to label that in green. And then the final segment it gives us is DE. It tells us that the entire thing is 44. So we want to figure out the length of DC and CE. So in order to do that, we want to set up an equation similar to this. We want to do this part plus this part equals the whole thing, just like we did here with 2 plus 8 equals 10. So it's going to be adding DC and CE to get the whole segment. So we can replace DC or substitute. Instead of writing DC, we can write what is given to us. So that is 1/2 times 4x plus 6. Then we're going to add CE, which they told us is 3x plus 1. And all of that equals DE, which is 44. All right, so now we can solve for x. We want to start off by distributing this 1/2 to both terms in the parentheses. So 1/2 times 4x is 2x, 1/2 times 6 is 3. And then none of this is going to change, so I'm just rewriting. All right, from here I can see that I have like terms on the same side of the equal sign, so I want to go ahead and combine these terms. So 2x plus 3x is 5x, and then 3 plus 1 is 4. I'm going to subtract 4 from both sides, and I get 5x equals 40, and then divide both sides by 5, so that gives me an x value of 8. All right, once I have this x value, I can plug it back into these, which I have labeled here, and I can get into these expressions so that I can get my distance or my length of those segments. So let's start off with this green one, the one that we highlighted in green, CE, and we'll do that one first. So CE equals 3 times x, well x is 8, so that's 3 times 8 plus 1. So 3 times 8 is 24, plus 1 means that CE equals 25. So this segment here is 25. And then I could absolutely take this x value, plug it back into this DC, and find out what DC is. However, I want to go a little bit easier and give you some other options. So if I have this total amount is 44, if I subtract this off, this 25, it's going to leave me with this leftover, which is DC, which is what I want. So think about it here. If we have the whole thing is 10 and I subtract off 8, I get 2, and that would be that section here. So we're going to do 44, kind of running out of room here. Let's go up here. 44 minus 25 equals, and so that means that segment DC is going to equal 97, or I'm sorry, 97, 19. All right, next one says that if B is between A and C, so again, I want to draw a picture because having that helps visualize it. So A, C, and B is between, doesn't matter where I put B, as long as it's between A and C. AB, it gives me as 1/4 16x plus 24, BC is 7x plus 15, and AC is 120. So I want to find AB and BC. So again, I'm going to set this up. I know that AB plus BC equals AC, because this little part here plus this part over here is going to equal this whole thing. All right, once I have that equation written out, I can substitute in the values that they gave me. So for AB, they said that that was 1/4 16x plus 24. BC is 7x plus 15. And AC is 120. All right, again, going to distribute. So 1/4 times 16x and times the 24. So it's going to give me 4x plus 6. And then nothing changes, so I just rewrite everything else. I need to combine my like terms here on the left-hand side. So 4x plus 7x is 11x. 6 plus 15 is 21. Going to subtract 21 from both sides. Divide both sides by 11, and I end up with x equaling 9. All right, then again, I want to find how long each of these segments are. So we'll start with AB, which is the distance from here to here. So AB is 1/4 16 times 9 plus 24. So I want to do what's inside. I have to follow PEMDAS, so I want to do what's inside these parentheses first. So 16 times 9 is going to be 144, and then I'm adding 24 to it. So that's going to give me a total of 168. So then I just multiply 168 by 1/4, and I end up with a distance of 42. And it's not giving us units, so it could be inches, feet, miles. It's just 42. All right, next one. We'll do BC in green. So we want to get the distance here. So we know that AB plus BC equals AC. All right, and now I know AB is this section here. It's 42, so I could say 42 plus, this is BC, which is what I'm looking for, has to equal the whole distance, which is AC, and we know AC equals 120. So that's how I'm going to set that up. I'm going to subtract this 42 from both sides, and BC equals 78. All right, next example, or actually next section, we're going on to segment bisector. So a bisector, if you think about what does the word, or when we say bicycle, we mean that it has two wheels. So bi means two. So when we talk about it in geometry, when we bisect something, it's going to cut, let's say cuts into two equal parts. So let's look at the definition. So the definition says a segment bisector is a line, ray, or segment that divides a line segment into two equal parts. So if we have this line segment, we'll say points, I don't know, A and C. We have this segment bisector, so something, a line, a ray, whatever, that comes through here and it bisects it. So we're gonna say that it's bisected at the point B. So this segment bisector is gonna be this right here. This is this piece that's doing the cutting. It's cutting AB into two. So when we want to note on a segment that two segments are equal, we're going to put a little tick mark like that. And then whatever other segment this part is equal to, we're going to put the same tick mark on there. So now we know that AB is equal to BC. So let's look at example 3. So example 3 says that EF bisects AD at the point C. So EF bisects. That means that EF is the one that's going to cut into two parts. So let's draw segment AD. And then EF is what's going to cut AD in half. So it's going to cut through AD. EF. And it enters or bisects at the point C. So this point right here is C. So if AD was bisected, that means it was cut into two equal parts. So these two segments are equal. So I know that AC equals CD. All right, so I got all of this information and I've only read this short little blurb right here. I haven't read anything else yet. So let's go on. If AC is equal to 5x minus 8 and CD is equal to 16 minus 3x, we want to find the value of x and of AD. So we see that they gave us a value for AC and they gave us a value for CD. So we can just substitute those right in. So instead of writing AC, I write 5x minus 8. And CD is 16 minus 3x. So then I just solve for x like I normally would. I'm going to add 3x to both sides, giving me 8x minus 8 equals 16. Add 8 to both sides, so I get 8x equals 24. And then I'm going to divide both sides by 8, and x equals 3. So there's the first answer that I was looking for. Now I've just got to find out how long AD is. So in order for me to find out how long it is from A to D, I need to find out how long it is from A to C, or from C to D. So let's see. Let's go with AC. So AC equals 5 times x, which is 3, minus 8. So 5 times 3 is 15 minus 8. So that means AC equals 7. So if AC is 7, and we know that AC and CD are the same length, that means CD is 7. So we know all we'd have to do to get AD is add those two segments together. So 7 plus 7 equals 14. All right, so let's look at example 4. It says that EF bisects AD at C. So EF is going to be the one bisecting. AD is the one that's being cut in half. And then it's that center point in the middle is C. So we know AC and CD are the same length. And then I'm going to go ahead and label this picture. So I've got AC is 3x minus 1. And then it tells me that AD is 12 minus x. Well, AD is the whole segment. So I can't set this up the same way I did here, but I can kind of combine the knowledge that I've gotten from both of these examples and use that to help me figure this out. So if AC is the same as CD, just like it was up here, 7 and 7, I can say that AC is 3x minus 1. I could also say that CD is 3x minus 1. So I can use that to help me get to a point to where I can set up an equation like I did up here in the first examples when we were doing segment addition. So we're going to do this segment, AC, plus segment CD equals the whole thing. So AC plus CD equals AD. And then we just plug in the information we have. So AC is 3x minus 1. Since CD and AC are the same thing, we just write 3x minus 1 again. And then AD is 12 minus x. Again, I've got multiple terms over here that can be combined. So I've got 3x and 3x, that is 6x. Negative 1 and negative 1 is negative 2. And then it equals 12 minus x. So I'm going to add an x to both sides. So 7x minus 2 equals 12. Add 2 to both sides, so that's 7x equals 14. And then divide both sides by 7, so x equals 2. So there's my first answer. I got my x value, and now I just need to find AD. So AD is the full length here. Since we kind of highlighted it in green, we'll do the work in green so that we don't get confused. All right, so AD equals 12 minus x, and now we know x is 2, so 12 minus 2. So AD equals 10. All right, last definition on this set of notes. So we're talking about the midpoint of a segment. So midpoint, that will help you remember, this mid means the middle. So a midpoint is the middle point. So just like we had in the example above, we didn't call it a midpoint, but it was a midpoint because it was exactly in the middle of A and C. So if we draw out here, it says a point on a line segment that divides two equal segments, the halfway point of a line segment. So let's just do one more. A, we'll say this is B, and then our midpoint goes right in the middle. I'm going to label it with an M. So if this is my midpoint, or my middle point, that means that it's the same distance from M to A as it is from M to B. So I'm going to go ahead and mark those as congruent, and that tells me that AM is equal to MB. Those little segments. Oh, I forgot my little. All right, so let's go on to this example over here. It says that M is the midpoint of PQ. So let's draw this out. I've got segment P and Q, and then M is my midpoint. So that means PM and MQ are equal. All right, so it tells me PM is 1/2, so from here to here is 1/2 10x plus 16, and then PQ, the whole segment, is 76. So from here to here is 76. So I need to figure out how to solve for x. So if P and M are the same, it's like having two of those up there, right? I've got this twice. So that's all we're going to do is we're going to just write this twice, 1/2 plus, times 10x plus 16. That's this first section from P to M, and then we need to write it again for from M to Q. So 1/2 10x plus 16 equals, and the whole amount is 76. So then we'll distribute 1/2 into each of these terms. So that gives us a 5x plus 8 plus, same thing again, distributing 5x plus 8 equals 76. Combine my like terms, 10x plus 16 equals 76. I'm going to subtract the 16 off of both sides, and I get 10x equals 60. Divide both sides by 10, and x equals 6. Kind of a tight squeeze in there with all this work. All right, so x equals 6. So I can figure out what each of these is going to be. I could use this x value to plug it back into here, or I could do something even simpler, and I could just divide this 76 into 2, because I know that it's divided into 2 equal parts. So if I do 76 divided by 2, I end up with 38. So each of these is 38. All right, last example. M is the midpoint of PQ. Let's go ahead and draw it out again. M is our midpoint. That means this side and this side, or this segment and this segment are the same. So it gives me PM, which is from here to here, and it also gives me MQ, which is from here to here. So since I know that these two segments are equal to each other, we can just set these two things equal to each other. So 9x plus 3 equals 11x minus 17. I'm going to subtract that 9x off both sides, giving me 3 equals 2x minus 17, adding 17 to both sides gives me 20 equals 2x, and then I divide both sides by 2, and I end up with an x value of 10. All right, so that gives me the first answer. Now I need to find out how long P to Q is. So I need to find the distance for one of these parts. So we can do, let's say PM. We'll find PM. PM is 9x plus 3. So 9 times x, which we now know is 10, plus 3. 9 times 10 is 90, plus 3 is 93. So PM equals 93. And since we know that these two segments are the same lengths, we automatically know that MQ is also 93. So in order to find this whole distance here from P to Q, all we would do is add those two segments together. So 93 plus 93 equals 186. And that's it.